Can you see the PPT?
Yes, yes, yes.
Yes.
Yes. Welcome back to our another session. Today we have one more eminent speaker, Dr. Manaswi Behera. She is currently working as Associate Professor of Environmental Engineering in School of Infrastructure, IIT Bhubaneswar. She received her master's degree in Environmental Engineering and Management from IIT Delhi and her PhD in Environmental Engineering from IIT Kharagpur. She has an extensive experience in the areas of wastewater treatment and reuse, waste management and bioengineering, bioenergy recovery using microbial fuel cell and biochemical system, and developing a cost-effective ceramic separator for fuel cell. She has 42 conference presentation and proceeding contribution, and she has published 50 referred articles in well-known journal. She also has published 2 books and 32 book chapter. She has completed 3 sponsored research project, and she is currently investigation Indo EU Consortium project Saraswati 2.0 with DST. She has guided 4 PhD research scholar, 15 projects of MTech students, and she is currently guiding 4 PhD scholar. She has granted a patent in 2022 for earthen pot based proton exchanger cum anode chamber and microbial fuel. Obtained thereof in recognition of her research work, Dr. Manaswi was awarded the Odisha Young Scientist Award by Science and Technology Department, Government of Odisha, and Best Scientist Award at the 11th International Conference in the Challenges in Environmental Science and Engineering 2018 at Bangkok. Dr. Manaswi is a member of several professional organizations and served as an associate editor for ASC Journal of Hazardous, Toxic, and Radioactive Waste. With this introduction, I request Professor Manaswi. So over to you.
Just a second. Can you see my slide?
Yes, ma'am, it's changing.
But here I think it is hanged in my system.
If it is hanging, you can stop it and reshare it, ma'am.
Can you see the front page?
Yes, ma'am.
Okay.
Yes, ma'am.
Good evening, all. Thank you, Professor Naveen, for giving me a chance to interact with all the eminent faculty members all over the India. So this is a very nice faculty development program, Waste to Wealth Innovation. I think this is the 8th lecture. You people have heard 7 lectures on waste to wealth, and my topic is energy recovery from solid waste through thermal conversion. So again, it is, I think, can I go without slideshow mode? Would be good, I think. Uh, Before moving towards the presentation, just look at this picture. So this is the history of Earth in a 24-hour clock. So you know in a day there are 24 hours. So since the beginning of the Earth's existence, so if we take the whole 4.6 billion years of planet Earth history and we compress it in 24 hours, meaning that the planet was born at midnight, suppose midnight 12, and we were at the next midnight just now. You can see like midnight it is started. Then modern human you can see at 23:59:56 hours. So we are just 4 seconds on this earth if it is 24 hours since the beginning of the earth. Now you can see the earth is existing from 4.6 billion years and we are here if earth is existing for 24 hours, we are there only for 4 seconds up to now. Okay. So here we are just simulating 1 second equals to 52,000 years and 1 hour equals to 187.5 million years. Okay. So why I am saying this? Because the way we are adjusting the world's all the resources, we are just creating the pollution. For that, we are studying the management, right? So Earth was existing before our existence. Earth doesn't need us. We need Earth for our existence. For that, we need to conserve our resources and we need to keep our Earth in a livable condition. For that, everything comes in the management. Like solid waste is a part, which is a major concern nowadays because in few years, India will be requiring the area for solid waste disposal, the area some of Bangalore, Hyderabad, Mumbai, and Kolkata, whatever is the area, that much area will be required for dumping the solid waste the way we are generating. Now you can see the population growth, world population growth through history. You can see like how future increment in 21st or 22nd century it will be model age. And we can see we will be soon reaching 12 billions in 2100. Okay, though the rate of growth is decreasing, but the population is rising. And quite accordingly, we are generating more waste. Our consumption is increasing and we are generating more waste, which is to be managed. Then here you can see another problem is in the solid waste management in this urban area. Okay, this figure shows the share of the total population living in urban area. You can see more than 50%, the green or dark green or the darker regions are the share of the population living in the urban areas. And you see not in India, other parts of mostly North America, South America or European Unions or in the Russia, most of and in Australia, most of the people they are living in the urban area. And this urbanization, you can see in the 19th century, 2 out of every 10 people lived in urban area. But in 2050, 7 out of every 10 people will live in urban area. So more than 70% of global population will be living in the urban area. So almost all the population growth expected in cities and towns of developing countries. And by 2050, the most populous country, India and China. In China, 70% population will be urban, and in India, 50% of the population will be urban. And more than 26 cities will be having 1 million. Okay. So, urban growth, it will require 100 to 200 million hectares of land. Okay. So another thing is there, you can see like Earth Overshoot Day. So this is in 2024, Earth Overshoot Day falls on 1st August. So before that, we'll learn what is Earth Overshoot Day. It marks the day when humanity has adjusted nature's budget for the year. Means suppose in 2024, what is Earth's population, whatever resources we are requiring, so whether it is actually existed in Earth or not. So whatever is existed, we have consumed for the entire year on 1st August. So after 1st August, whatever we are consuming, we are just taking it from our future need, from next year's need. Okay, for the rest of the year, we are maintaining our ecological deficit by drawing down local resource stocks and accumulating carbon dioxide in the atmosphere. Okay, you can see the earth overshoot there. It is decreasing and it is coming early year by year. Last year it was 2nd or 3rd August. Is this year it is 1st August. Okay. So in that context, if you will see the trends in the solid waste generation, so the world generates around 2.01 billion tons of municipal solid waste as per the World Bank data in 2024. So we are generating 2.01 billion tons of MSW. So at least 33% of that is extremely conservatively not managed in an environmentally safe manner. You can see the left side curve. Here you can see the high income countries. They are managing 96% of their municipal solid waste generation. But low income countries, only 39% of the solid waste are being collected and treated. Okay. So if you see the projected waste generation by region, we are in South Asia. So 661 million tons of solid waste will be generated by 2050, and it is also increasing for every continent. So next, coming to before going to the solid waste management, all of us must have gone through this page. Some other presentation might have included this also. That is the Sustainable Development Goal by the UNESCO. So here you can see there are 17 goals. So out of that, one thing is sustainable cities and communities, and another thing is that clean water and sanitation. Okay. In sanitation also, solid waste also making a part when we are dumping the solid waste in the receiving water bodies. So it is also polluting the drinking water supplies. And also in case of sustainable cities, when we have to maintain a city in a sustainable manner. So in that way, we have to see like our solid waste which is generated in the city is well managed. So to attain that 11 number goal, at least solid waste management is required. So now coming to solid waste management. Now refer to this figure. This we cannot say a landfill. This is just a dump site where everything which we are not using, which is not of our use, we are just dumping. See that if it is a properly managed way, to segregate the waste in different bins. But in most of the Indian cities, it is not happening. So, as far as possible, we have all the rules, Solid Waste Management Rule 2016, where we have there should be proper segregation at source, proper collection, proper transportation. Then, as per the solid waste management hierarchy, it should be managed, but it is not happening.
ठीक है
Okay. Now, if we say this integrated solid waste management hierarchy, there is a traditional waste hierarchy which is managed by many of the cities. And as per the solid waste management rule, there is a new waste management paradigm. So, in a conventional thing, we can see the composition of MSW in India. Biodegradable fraction is 20%, recyclables are 20%, inert 22, and others 8%. Okay. So, uh, if we see the traditional waste hierarchy, so volume of the waste managed, if we see, we are mostly dumping most of the waste in the landfill. But to attain the sustainable goal or to attain the circular economy, we have to go or we have to shift the paradigm towards this new waste management, where the least preferred should be the landfill disposal and the first option should be waste prevention or refuse or reduce. So, through product design and producer responsibility, we can reduce the use of the solid waste. Then, after use, we should be focusing on the reuse, which is the next option. Then, the next option is recycle. After reuse, it should be recycled to its original product or some other product. Then, it should be again reused. Then, next thing is conversion or compost. In compost means it is the biodegradable fraction, so which is composted to get the manure. Then next option is transformation or waste to energy. So this waste to energy, it can be biochemical, it can be thermochemical. Biochemical means suppose the biodegradable fraction like the food waste or yard waste, all these waste can be taken for anaerobic digestion for methane generation or the non biodegradable fraction, it can be taken for thermal conversion. So that in that way we can generate uh, energy from the waste. So and the rest part which cannot be reused, recycled, or which cannot be composted, which cannot be used for waste to energy facility, that can find its way to the disposal, that is the landfill. And the today's topic is uh, waste to energy through thermal conversion. So we will be focusing on the thermal conversion. So what is thermal conversion of solid? So these processes are the methods for treating the solid waste by heating it at high temperature to break down the organic matter. So these processes can reduce the volume of the waste up to by 80%, and also at simultaneously we can recover energy so that we can make waste to energy facility through thermal conversion. So this thermal conversion we can classify as incineration, gasification, pyrolysis, or plasma arc gasification. So incineration is a complete oxidation process that burns waste at high temperature to produce ash, flue gas, and heat. Whereas gasification is a partial oxidation process that uses a controlled amount of air or oxygen to produce syngas, which can be used to generate electricity. Then in pyrolysis, thermochemical decomposition process that occurs without oxygen, producing mostly solid, liquid, as well as gaseous products. So the primary product are biochar, which is a solid residue, then bio oil, liquid residue, and syngas. Then the last one is which is mostly in the research stage, that is the plasma arc gasification, where this is a process that uses an electric arc to heat waste to very high temperature. Then we'll go one by one. What is incineration? So we know incineration is the combustion of the waste at a very high temperature in the presence of oxygen, and it results in the production of ash, flue gas, and heat. So incineration is a feasible technology for combustion of unprocessed or minimum processed waste. Here, the processing of the waste is not that much exhaustive. So, the waste can be segregated, and with least pre-processing, it can be uh, uh, used in the incinerator to generate heat and energy. The potential for energy generation depends on the composition, density, moisture content, and presence of the inert in the waste. So, about 65 to 80% of the energy content of the organic matter, it can be recovered as heat energy, which can be utilized either for direct thermal application or producing power via steam turbine generator. Then incineration of MSW helps to reduce the landfill volume. As I said, generally, incinerators are preferred near to landfill dump site where the segregation happens. If the source segregation is not happening, so they can send as much as possible the amount to the incinerators so that the load on the landfill reduces. Then incineration is feasible and there are no better option for processing the waste, that is shortage of land for landfill. uh, Suppose Japan, it uses incineration because they have very less land available for the disposal or dumping of the waste. On the downside, incineration is expensive and as remaining after the process completion can be harmful for the environment because if it is not treated properly, it may contain toxin, it may contain heavy metals. So proper disposal after treatment is required. Then, what is the incineration objective? One is volume reduction. So, weight of the solid waste to be dealt, which is reduced by 70 to 75%. Then, stabilization of the waste. Incinerator output, like that is ash, is considerably more inert than the incinerator input, that is the solid waste. Then, recovery of energy from waste. So, we can, do the treatment of the solid waste, we can generate heat. Again, it can be used for electricity generation. Finally, it also sterilizes the waste. This is the primary importance in the incineration of clinical or biomedical waste. Mostly, all the hospitals, big hospitals, they have their own incinerator for the sterilization of the biomedical waste. So, incineration also ensures destruction of pathogen prior to final disposal in the land. So, which kind of waste can be used as a fuel in case of incineration? So, the primary difference between waste incineration and other combustion system like pyrolysis or gasification is that the waste incineration process treats incoming waste with great variation. So, different type of waste composition can be fed into the waste incinerator, but the operating parameters should fall within a range for the energy recovery. So there is a this table source, like the source is like manual of MSW management. So it says like moisture content should be less than 45%. Organic or volatile matter should be greater than 40%. Fixed carbon should be less than 15%. And total inert should be less than 30%. And the calorific value of the waste should be greater than 1500 kilocalories per kg. So before designing any incinerator, so basic considerations are like waste available data on the amount and composition of each waste type. It is not like we take a single day or 1 week data and design an incinerator. We should have a good database on the type, composition as well as quantity of the waste that is being generated and effect of the future changes in the waste management, like in future, in near future, if there is a chance of taking up other technologies as a viable option to incinerator, then this plant may not be in use. So we have to take care of this because the installation cost is and operation cost is used. We have to take care of the effect of future changes in the waste management also, while considering the design of a incinerator. So waste led to incineration plant consist of domestic, commercial, institutional and industrial waste. So there is a great variation in waste composition, but we should avoid the sweepings and construction demolition waste. So they are not suitable. They have a high inert content and they are not suitable for incineration because large fraction here in combustible matter. So, what are the key parameters in characterizing waste as a fuel? So, it is the heating value, the heat generated per unit weight or volume of combustible material completely burned. Then heating value is roughly proportional to the waste that is combustible, excluding the moisture and ash content and to the carbon content of the combustible fraction. So then also moisture content, it is a critical determinant in the economic feasibility of incineration process, since energy that must be supplied for evaporation of water and in raising the temperature of the water vapor. It is generally found to be high in waste containing a higher proportion of food waste. So moisture content should be less than 45% if it is to be fed to an incinerator. Then ash content, it is a ash content substance left after ignition at high 50%. Then how we will characterize this waste for which will be fed to the incinerator through this Tanner's diagram. So here we can see a Tanner's diagram in triangle. One axis is combustible, one is moisture, another is ash content. And the moisture content should be 15 to 35% when drying at 105 degree. Then ash content or inorganic content should be 10 to 25% after ignition at 550 degree. And combustible solid or organic solid typically 40 to 65%. So all these characteristics can be used in the Tanner's diagram to examine if the waste can be combusted without any auxiliary fuel. Uh, so here you can see the combustion process doesn't require auxiliary fuel. Auxiliary fuel means some extra additional fuel are to be added if the moisture content is more or the ash content is more or combustible solids are less. So we do not need anything if the moisture content is less than 50%, ash content is less than 60% and carbon content is greater than 25%. You can see this red marked area of the standard diagram. If the waste characteristics fall into this shaded area, then without any auxiliary fuel requirement, the incineration can happen. Then heating value. So we generally calculate the lower heating value and higher heating value. Like some variables, they are like energy released upon complete combustion of a fuel, carbon to CO2, hydrogen to water, sulfur to sulfur dioxide, and water is evaporated, leaving the process in its evaporated state. That whichever energy will be released, that is the lower heating value, and the higher heating value is the energy released as complete oxidation and water leaves the combustion process in its liquids. It expresses the theoretical maximum energy release from the fuel. So the difference between lower heating value and higher heating value is the heat of condensation of the water vapor content in the flue gas originating from the moisture in the waste and moisture generated by the oxidation of hydrogen bound within the chemical structure of the waste. Then incineration process, how it happens in the incinerator, there is a furnace. So in a furnace, the combustible component react with oxygen. In the solid waste which are to be incinerated, they are kept in that furnace and oxygen is supplied or air is supplied. So releasing a significant amount of hot combustion gas. The moisture content of the waste is evaporated in the initial stage of the incineration process and the incombustible part of the waste from the solid residue that is bottom mass and fly ash. Through incineration, the solid constituent undergo a range of processes as a result of exposure to heat and contact. The combustion gases pass from the furnace to the afterburning chamber. As per the European Union standard, a minimum temperature of 850 degrees centigrade for municipal waste and 1100 degrees centigrade for certain types of hazardous waste have been set for the complete burnout of the combustion gases in the afterburning chamber. So, as per the European Union, these temperatures should be maintained for a minimum residence time of 2 seconds, as measured from the last injection of the combustion. So, you have strict legislation as no feeding into the incinerator before attainment of the required temperature. Means once the 850-degree temperature is attained, then only feeding should be done and a required residence time of 2 seconds should be given. So if there is any interruption such as drop in the temperature, then feeding should be stopped right away. So in India, as per the CPHO manual 2016, minimum gas phase combustion temperature of 850 degrees centigrade for municipal solid waste and a minimum residence time of the flue above this temperature of 2 seconds after the last incineration air supply should be followed. So, what is the pre-treatment required to the solid waste for the incineration? Depending on the quality of the waste and incineration system, some pre-treatment techniques may be necessary, which involve sorting, homogenization of the waste before incineration. So we have to sort out uh, inert materials and the waste for proper mixing or a uniform waste should be fed. So homogenization of the waste is required. And for mass burning incinerator, the pre-treatments are like removal or shredding of bulky or heavy items, then mixing of low and high heating value. Then for homogeneous waste, pre-treatment are like shredding for homogenization of the waste, screening for narrowing the particle range to the fluidized waste, then removal of metallic iron with magnets. So these are the pre-treatments. Then a mass burning incineration. So in most of the incinerators installed, they are mostly mass. So this facility typically consists of a reciprocating great combustion system and a refractory line water valve steam generator. So this mass burn system generally consists of either two or three incineration units ranging in capacity 50 to 1000 tons per day. So these facilities can accept refuse that has undergone little pre-processing. That's why it is called mass burning system. Little pre-processing other than the removal of oversized items. So although this versatility makes mass burn facilities convenient and flexible, so local programs to separate household hazardous waste like minerals, pesticides, or recover certain material like iron scrap, these are necessary to help ensure environmentally viable incineration and resource conservation as well. It is not like mass burning means all the MSW will just dump. So bigger size particles as well as the metals should be removed before feeding to the mass burning incinerator. Then, because of larger facility size, incineration unit is specially designed to efficiently combust the waste to recover greater quantities of steam, electricity for energy. So to achieve this greater combustion and heat recovery efficiency, the larger field-directed incinerators are usually inline furnaces with grate system. So again, the mass burning system can also be achieved by use of a rotary kiln. Rotary kilns use a turning cylinder, either a retractor or water wall design, to tumble the waste through the system. So here the waste rotates for better mixing and better contact with the fuel. Then the waste intake area usually includes a tipping floor, pit or crane. I'll show the photograph later. Then at least two combustor units are included to provide a level of redundancy to allow waste processing at a reduced rate. So mass one facilities generate a higher quality of steam with high pressure and temperature, which is then passed through a turbine generator to produce electricity or through an extraction turbine to generate electricity as well as provide process steam for heating or other purposes. So this is the diagram of a mass burning system. Here you can see there is a receiving feed which receives the number one is the receiving feed. We receive the waste, then charging crane. Then there is a through that crane the waste is taken to the feed hopper. Then the grate system. Number four is the grate system. So then steam generator is there after burning. The steam is generated and heat exchanger then the heat is utilized for steam or for electricity generation. Then after that, the flue gas treatment system, acid gas spray, dry scrubbing system is used for the acid gas removal. Then particulate collection systems are there that may be of settling chamber or cyclone type of thing to remove the particulate matter, mostly PM10 or PM2.5 or PM1. So they can be particulate collection, PM10, heavier particles are generally collected from the um, cyclone or gravity settling chambers. And in stack, there is a stack, the flue gas is emitted. There can be electrostatic precipitators or back filters installed to remove the uh, lesser size of the particle like 2.5 or so. This is the mass burning incinerator system where all the waste are uh, generally uh, fed into the reactor and mass burning of the waste occurs. Then also in incineration, refused derived fuels can also be fed as the, to get better efficiency. So what is RDF? So it is defined as the fuel derived from the combustible waste fraction of solid waste like plastic, wood, pulp, uh, then organic waste other than chlorinated materials mostly in the form of pellet or fluff produced by drying, shredding, then dehydrating. First waste is dried, then it is comminuted or shredded to smaller size, dehydrated, then compacted to solid waste granules. Then composition of RDF has higher concentration of combustible material than those of the parent mixed MSW since here some segregation has happened and also it is the waste has been dried, the moisture content is reduced, so it has higher concentration of combustible matter. So quantity of RDF produced per ton of MSW varies depending on the type of collection, reprocessing, and composition of the waste source. So quality of RDF depends on the characteristic of incoming waste field, segregation into combustible and non-combustible is a prerequisite. So as we can say this hierarchy. So the in the waste to energy thing, we can use this RDA incinerator to generate the energy. Then RDF production facilities make RDF in various forms through material separation, size reduction, and pelletizing. Although RDF processing has the advantage of removing recyclables and contaminants from the combustion system, on an average, capital cost per ton of incineration unit that use RDF are higher than that of the mass burning or other incineration option. Because making RDF requires another setup, which is costly. So, which makes the operation as well as the capital cost more than the mass burning. So RDF production plant like mass burn incinerator characteristically have an indoor tipping point. Instead of being pushed into a pit, waste in the RDF plant is typically fed into a conveyor, which is either below grade or hopper. So here you can see, like there, yeah, in a pit, this municipal solid waste was dumped, but here we can see uh, through conveyors, RDFs are fed into the combustion chamber. This is another type of incinerator, moving grade incinerator. Like conventional mass one incinerator based on a moving grade consists of a layered burning of the waste on the grade that transport the waste to the furnace. So on a layer by layer, generally the waste is fed and the overhead crane feeds the waste into the hopper where it is transported via a tube to the grate furnace. On the grate, the waste is dried and then burned at high temperature while air is used. So, what is the advantage and disadvantage of the moving grate incinerator? Like it can accommodate large variation in waste composition and heating value, and can be built in a very large unit up to 50 ton per hour. But the disadvantage is the plant installation cost is very high and the maintenance cost is also relatively higher. Then another type of incinerator is rotary kiln type. Here this is another mass one incinerator based on the layered burning of the waste in a rotating cylinder. The combustor rotates. This is a request to the participants. So they are requesting for the attendance sheet and is continuously blinking on the slides. I'm unable to see it. Uh, Professor Nabin, if you can take care of this. The material is transported through the furnace by the rotation of the inclined cylinder. The cylinder rotates. Then the rotary kiln is usually a refractory line and it is equipped with water wells. The diameter of the cylinder may be 1 to 5 meter, and length is 8 to 20 meter. And the capacity should be within the range of 2.4 ton per day to 480 ton per day. Then the kiln rotates with a speed of around 3 to 5 rotation per hour, and the excess air ratio is well above that of the moving grate incinerator and the flue gas. So here more air is required, and this is the photograph is a rotary kiln incinerator in China, in Henan province, China. And the energy efficiency here it doesn't exceed 80%, as the retention time of the flue gas usually is too short for complete reaction to take place in the rotary kiln itself. The cylinder is followed by an after burning chamber because the complete combustion of the flue gas is not happening in the cylinder. So there is a after burning chamber which may be incorporated in the first part of the boiler. And the rotary kiln may also be used in a combination with a moving grate, where the moving grate forms the ignition part and the rotary kiln forms the burning out section. So the advantages and disadvantages of this type is mostly similar to moving grate incinerator energy, but the energy efficiency is lower than the moving grate incinerator. And the disadvantage is plant installation and maintenance cost is relatively higher, and rotary kiln may be rarely used for new MSW incineration plant with high heating value waste, because if the waste has high heating value but the energy efficiency of the rotary kiln incinerator is less, then the energy efficiency or energy recovery will be less. So most of the waste energy content will be wasted. Therefore, this is not preferred. Then another type of incinerator is fluidized bed incinerator. It works on the principle where solid particles mixed with the fuel are fluidized by air. So here generally the bed fluidizes. The solid particles are in moving condition inside the incinerator. So by fluidization, so the fuel and the solids, they are suspended in an upward air stream. So the solid waste behave like a fluid. So because the fuel and solid are mixed and they are suspended in the upward air stream. The reactor usually consists of a vertical refractory lined steel vessel containing a bed of granular material such as silica sand, limestone, or a ceramic material. So over that, the solid waste is kept, and if the air is allowed to flow through this bed, it makes the solid waste remain in suspension inside the incinerator. So there is a better contact between the solid waste and fuel, and the incineration efficiency is better. So fluidization of the bed is ensured by air injection to a large number of nodules in the bottom of the incinerator. So it causes a vigorous agitation of the bed material. So the incineration occurs in a close contact with the bed material and combustion air allowing relatively low excess air level. And here the thermal efficiency is very high, up to 90%. So here you can see a fluidized bed incinerator in Hankin, USA, and one in Japan. So the advantages of this type are reduction of dangerous substances in the fluidized bed reactor, flexibility regarding low quality fuels or cost. NOx generation may be low due to relatively low and well controlled combustion temperature. Then the burnout of flue gas and particle is very good, and capital and maintenance costs are relatively low than other type of. Then a disadvantage is demanding pre-treatment for smooth functioning. Preliminary useful, it is mostly useful for homogeneous waste type, which include liquid waste. So then coming to the practical application, there are many incinerator plants installed, but I think now only 12 incineration plants in India are operational. Many are installed but not functioning. So this is a case study for the first waste incineration plant in India, quite failed. So in 1987, Ministry of Non-Conventional Energy Sources commissioned the Timarpur Refuse Incineration cum Power Generation Station at a capital cost of 20 crores, which was imported from Denmark. The plant itself was imported from Denmark, and it was designed to incinerate 300 tons of MSW per day to generate 3.75 megawatt of heat. So plant was shut down after 21 days trial operation due to poor quality of incoming waste. So therefore, as I said before, we have to properly identify the waste quality as well as quantity. And as I said, the operating parameter, there is a particular operating parameter that should be maintained for the efficient incineration, but this plant failed within 21 days of its trial. So the calorific value of the supplied waste was in the range of 600 to 700 kilocalorie per kg, while the required waste with net calorific value is 1462.5 kilocalorie per kg. It was designed for that, but the waste which was coming was having less than 50% of the required calorific value. Then attempt to supplement the combustion with diesel also failed. Then ministry incurred an expenditure of 1.25 crore on maintenance and insurance of the plant. The project was officially shut down in July 9. So it was a failure, the first incineration plant. Then next is Narela Bhavana Waste to Energy Plant, Delhi. So the news article says India's largest solid waste to energy plant launched at Delhi at Narela. So North Delhi Municipal Corporation launched waste to energy plant in the year 2017, and the project is using 2000 metric ton of waste every day to generate 24 megawatt of energy. The project is spread over 100 acres of land. Rupees 458 crore has been developed on PPP model by Ramki Group, which is a Hyderabad-based waste management company in collaboration with North Corporation. As per the agreement, the electricity generated from the plant will be sold by the concessionaire. At the waste to energy plant, there are two boilers which run at its full capacity to consume 600 tons of RBI. And the facility comprises a scientifically engineered landfill, Narela Bhavana first in Delhi. So in the landfill, actually, whatever waste comes, there the segregation happens. So which are not combustible, they are generally dumped. The rest goes to the incineration part after taking out the recyclable fraction. In the solid waste is collected door to door from household in Rohini and civil lines and transported to the landfill, which goes to the MRF. In landfill side, there is a MRF, means material recovery facility. So in that there, the MRF reclaims metals and other recyclables, so it's great value, and produces compost out of the organic waste. The waste is further segregated to obtain RDA, which is burnt above 1000 degrees centigrade to produce electricity. And the fly ash generated is less than 20% of the fuel, which is carefully dumped in the landfill. So this plant alone handles about 20% of the waste. And apart from that, um, uh, Delhi has two other waste to energy plant at Gazipur and Okhla landfill site. And the Gazipur plant uses about 2000 tons of garbage and produce 12 megawatt hour energy. And the Okhla landfill waste to energy plant has a capacity to produce 16 megawatt capacity from 1200 tons of garbage. So Okhla waste to energy plant, that is another case study. So Okhla landfill waste to energy plant in South Delhi has a capacity of 16 megawatt capacity, and it creates 1200 tons of garbage. Incineration plant, it was commissioned in January 2012 and is processing about 1600 ton per day of waste. And after pre-processing, it is being fed into the incineration plant and generating about 16 megawatt of electricity. But why the incineration plant, they are facing lot of criticism. Here it says we don't want electricity at the cost of lives. Toxic impact of Okla's waste to energy plant. So like this waste to energy plant in Delhi faced continuous protest for polluting the environment. Mostly the residual emission and the associated health hazard with that. Mostly the emissions are particulate matter emission or the acidic gases. Then coming to the next thermal conversion process, pyrolysis. So what is pyrolysis? So pyro means fire and lysis means separating. So here what happens? There are a step of reactions where the molecular breakdown of larger molecule into smaller molecule, the presence of heat happens. So pyrolysis, it is also known as thermal cracking or only cracking, thermolysis. So there are so many synonyms of pyrolysis. So here, what happens? You can see here the example of, suppose the biomass here is wet wood. So here what happens? In the absence of oxygen or limited supply of air, so heat flows in and then the material is dried, torrefied, then biochar is produced, and with different incoming temperature, even other end products like bio oil or syngas can be produced from different feedstocks. So here heat flows in and out of the biomass and char slowly, and it takes about 1 hour for charring to penetrate 30 mm into the wood, and charring process at about 0.5 mm per minute. So what are the feedstock for pyrolysis? So it should have a particular optimum moisture content around 10%, because higher moisture content produces high level of water and lower moisture content produces dust instead of bio oil. Then particle size is also another factor affecting the pyrolysis. Like efficiency and nature of the pyrolysis is dependent on the particle size. Small particle to a maximum of 2 mm for rapid heat transfer, because anyway final thing is like heat should be transferred from outer to the inner of the particle. So the less is the particle size, the better will be the heat transfer and better pyrolysis. So the other factors like that affect the pyrolysis processes are pyrolysis temperature, heating rate, moisture in the garbage, types of pyrolysis unit, as well as supply of oxygen. So, depending on the process parameters, the pyrolysis can be classified as flash pyrolysis, fast pyrolysis, then slow pyrolysis, and microwave pyrolysis. So, flash pyrolysis is like heating temperature between 400 to 600 degrees centigrade. Fast pyrolysis occurs at a temperature of 650 to 1000 degrees centigrade. Slow pyrolysis generally it is a slow process than the first or fast pyrolysis, and prevailing temperature is around 500 degrees centigrade. And microwave pyrolysis, heating temperature 200 degrees centigrade, but it happens in a microwave reactor. All of us have a many of us have seen the microwave. We are using for cooking purpose at home. So similar type of reactor is generally modified for the pyrolysis of the solid waste. Like there should be inert gas provision, and through micro heating, uh, uh, with the heating, we can do through microwave pyrolysis. What happens? Like proper heating from all the direction, uniform heating of the biomass happens. So we get whatever end product is of good quality. The bio oil, the heating value will be better. If biochar we are producing, the surface area which is produced through microwave pyrolysis is better than other pyrolysis process. Then here some comparison like slow pyrolysis, the residence time of the gas may be over 5 seconds. And during slow pyrolysis, tar and char are released as main product as the biomass is slowly devolatilized. Then in fast pyrolysis, biomass is rapidly heated depending on the desired amount of bio oil or gas products. Char is accumulated in large quantities and the yield is about 60% of the bio oil. Then flash pyrolysis is like residence time of gas is less than 2%. Then produce fewer amount of gas and tar when compared to slow pyrolysis, and 75% of the biomass, bio oil yield is there. Then microwave pyrolysis, it is a first pyrolysis process, and here the fast pyrolysis gets the benefit of the microwave heating. It reduces the time taken to initiate the pyrolysis reaction. Suppose if another pyrolysis takes 1 hour, can be obtained 10, 20 minutes or even less than that. It reduces the time taken. Then microwave bio oil could be used as a replacement crude oil also. So there are different types. How to choose means our objectives would be like what should be the end product, whether we want biochar or bio oil. If we want biochar, then we should go with the slow pyrolysis or fast pyrolysis with some process modification. If we want bio oil at higher concentration, we can go for fast pyrolysis. And in microwave pyrolysis, we can play with the microwave power as well as the microwave time or the feedstock composition to get whether bio oil, we want bio oil more or biochar. So depending on the end product or uses of the end product, we can select which type of pyrolysis we want. Then some pros and cons of the pyrolysis. Simple, inexpensive technology and environmental friendly. So if it is saying inexpensive means sometimes inexpensive maybe capital cost, but the operating cost is, and it's better waste management because uh, there is usable end product. Unlike incinerator, bottom mass is to be uh, um, like managed, but here there is no bottom mass or any ass is produced. Whatever end products are generated that are again used, either biochar or bio-oil. So reduce the country's dependence on imported energy resources. So then what are the disadvantages? Requires dry product. The moisture content should be less. So it requires pre-processing. So huge quantity of solid waste when we go for pyrolysis, it requires drying. Means moisture content should be as low as 15%, 10%. So in drying, lot of area requirement is there. So in lab scale, what people are doing, they are doing oven drying and they are doing the pyrolysis. Practically, it is not possible when 1,000 to 2,000 tons per day MSW is generated. So open drying will take time. For that, use area is required. So that is a major disadvantage of pyrolysis. Being ineffective in destroying and physical separating inorganic compound from the contaminated. So whatever biochar is produced or bio oil is produced, generally it may contain the uh, undeserved material. So many toxic material may be there in biochar. So many toxic or inorganic compound may be there in bio oil. So bio oil without proper treatment or proper purification, bio oil generated from the pyrolysis cannot be used directly. So it requires proper treatment, storage, and disposal of hazardous. Then types of pyrolyzer, one is bubbling fluidized bed. Like fluidized, what is fluidized bed? I have already told you. Like some wet material is there, over that gas is injected and the solid waste is fluidized or it is kept in suspension. So the residence time of here, what happens? The residence time of the vapor and solid are controlled by the fluidizing gas flow rate. And during the pyrolysis reaction, char acts as a catalyst in cracking vapor, and the end products are oil vapor, gas, char, and aerosol. And there is also circulating fluidized bed where the uh, pyrolyzer circulates. It has similar characteristics that of bubbling bed pyrolyzer, excluding that the residence time of the vapor. And the char is faster due to higher gas velocity. And another type of pyrolyzer is ablative pyrolyzer. Here, as you can see from the figure, like there is a uh, reactor wall which tends to soften the feedstock under pressure. So, if wood is to be pyrolyzed, a pressure is applied to wood, the disc is spinning, and large feedstock particles they can be pyrolyzed in this pyrolyzer, as the reaction rate are not influenced by the heat transfer via biomass particles. They are generally first softened, then pyrolyzed. So the method of pyrolyzing the biomass, it can be of external heating of the biomass or internal heating of the biomass. In internal heating, what happens? Sufficient air is provided to maintain combustion, and above or below the biomass, air is introduced, and heat from the flame pyrolyzes neighboring biomass, liberating more gases to sustain the process. And flame around the charred biomass consumes the oxygen and protects the char from oxidation. Whatever generally pyrolysis is in the absence of oxygen, but anyway, if we are providing not providing inert gas, oxygen, some oxygen may prevail in the fuel gas. So in that case, uh, there is a flame around the charred biomass. It is there which consumes oxygen, so that the the biochar which is produced, that is not oxidized, and the excess secondary air is introduced to fully and cleanly combust liberated gases above or separated from the biomass. And in case of external heating of the biomass type of pyrolyzer, separate source of heat is applied to the vessel containing the biochar from outside. It is inside, there is no burning, and heat can be recycled to continue the process. And the major disadvantage is that it takes a long time to penetrate a large. If the size of the pyrolyzer is more and it is processing large quantity of the solid waste, then it will take long time for the heat to penetrate to the MSW and reach all the solid waste particles. and if built and operated carelessly, or it can explode also in case of this external heating of the biomass. So some of the advantages are like it is simple, pyrolysis is simple, low cost, and capable of processing a wide variety of feedstock, producing gases, bio oil, biochemical, and charcoal. And it reduces greenhouse gas emission and waste going to landfill, produces a marketable product like electricity, and low risk of water pollution, low risk of odor, high recovery rate of resources, minimal risk of health consequence, commercially proven. Commercially proven, why I'm saying, because biochar which is produced, many researchers have shown like it can replace the commercially available fuel. Bio oil can replace crude oil, but there is a disadvantage is like it is still evolving. All these results and advantages which are shown are based on the laboratory or at least pilot scale. Commercial scale, large scale implementation and success stories are very, and market are yet to be developed for char product and pyrolysis, because the post processing requirement of the biochar as well as the bio oil, because it cannot be directly used uh, in the uh, pyrolysis. Then the next technology is gasification. Gasification is a process that converts organic or fossil-based carbonaceous material at high temperature, mostly above 700 degrees centigrade, without combustion. With a controlled amount of oxygen or steam into carbon monoxide, hydrogen, and carbon dioxide. Here you can see the flow chart for biomass displayed. Biomass like rice husk, sawdust, coconut shell, or segregated part of the MSW. Then in the gasification reactor, the air is introduced, and without conversion, at higher temperature, the solid waste is converted to synthetic gas like carbon monoxide, H2N2, tars, and dust. And next phase, the synthetic gas cleaning occurs, and carbon monoxide reacts with water to form carbon dioxide and more hydrogen via water gas shift reaction. Observer or special membranes can separate the hydrogen from this gas stream. So in gasification, mostly solid waste is converted to producer and producer gases, then clean gaseous fuel to end use. So in biomass gasification, at low temperature gasification, producer gas is generated. So mostly CO, H2, methane. Then at high temperature or catalytic gasification, syngas, mostly CO and H2 are produced. So, moreover, gasification is a thermochemical process. It converts any carbon containing material into a combustible gas by supplying a restricted amount of oxygen. So, in case of biomass feedstock, this gas is known as wood gas, producer gas, or syngas, which composed primarily of carbon monoxide and hydrogen as fuel, together with small amount of methane. It will also contain other compounds such as sulfur and nitrogen oxide depending on the chemical composition of the solid waste. Then under typical gasification condition, oxygen level are restricted to less than 30% of that required for complete combustion. Producer gas as well as syngas. Then gasification agents. The oxidant for the gasification process can be either atmospheric air or pure oxygen. So air gasification of biomass produces a low calorific value or low megajoule gas, which contain about 50% nitrogen and can fuel engine and furnaces. Then gasification of biomass with pure oxygen results in a medium calorific value or medium megajoule gas free of nitrogen. So this system also offers faster reaction rate than air gasification, but has the disadvantage of additional capital cost associated with pure oxygen. Then syngas, what is the gasification end uses? Syngas or the producer gas can be burned to create heat or electricity. It can be converted to methane and fed into natural gas distribution system. Then syngas can also be converted to methanol, ethanol, or other chemical or liquid fuels. Then methanol produced through gasification can be further refined into uh, biodiesel with addition of vegetable oils or animal fat. Then use of gasification for generation of fuel chemical and power. So, what are the advantages of biomass gasification? Uh, it produces a more convenient, easily controllable form of cleaner fuel for both thermal energy and electricity generation. Then gasification gives biomass the flexibility to fuel a wide range of electricity generation systems, like it can be used in gas turbine, fuel cells, or reciprocating. Then wide variety of biomass material can be gasified, mainly which would be difficult to burn otherwise. Then gasification offers one means of processing waste fuel, many of which can be problematic. Then gasification has the potential of reducing emission of pollutant and greenhouse gases per unit energy output. Projected process efficiency are higher than the direct combustion system and comparably fossil fuel gas. Finally, what are the challenges of utilizing pyrolysis and gasification in the industry? So, we need high calorific value waste, which may otherwise be processed in more sustainable processes, is required as feedstock. Organics can be converted into compost in a much more cost effective and environmentally safe against using them for these processes. It requires specific feedstock quality, which has a direct impact on the efficiency and commercial viability of the product. Retreatment of the waste is a must, and specific size and consistency of solid waste should be achieved before NSW can be used as feed. Then, what are the features of a well implemented waste to energy? So, it reduces volume of the waste with minimal or no waste sent to landfill. That is the major objective of the waste to energy plant. It is not like that we are generating energy, but we are also generating some byproducts which again require some disposal. So, the major objective should be it should reduce the volume of the waste be managed further. Then generates energy through gas, power, and fertilizer, ensuring waste is utilized thoroughly. Usable solution in small town along with large urban center. Decentralized process with minimal transportation and absolutely no hassles. Then emissions should be aligned with defined environment norms. Like as I said, we could see that news article, people wanted the Ofla treatment incinerator to be closed because of the pollution it was causing. Then the major thing is economical implementation and financially viable. So everything we should see financial thing in terms of money or economy, as well as also we should see the as an environmental engineer, we should see the environmental cost of the system also. It is, even though if the technology sometimes it is taking less money for the operation or capital cost, but what is the environmental cost behind it? Is it polluting the environment? What is the carbon footprint? It should be also taking care of the circular economy. I think it was discussed in the last lecture. What is circular economy? Um, when we are considering a particular product, it is not like that the incinerator plant or it is generating electricity. So, in case of circular economy, we should be thinking of how much waste is being transported to that. For transportation of the waste, what is the cost involvement? What is the fossil fuel used for the transportation of the waste to that locality? For the operation, whatever other auxiliary fuels are used. So, what is the carbon footprint of that? It is not only that how much power is being generated for the incinerator. We should be also focusing like that for the operation, how much carbon footprint is involved. So, what is the environmental cost for that? How much emission it is creating? So, all everything should be taken care. into the while doing the economical implementation. It should be a must. The environmental cost should be included in any kind of waste management facilities. It is not like that to manage one waste, we are generating other type of. And at the end of the day, it should be financially viable and easily acceptable by the people. Thank you for your patient hearing. With this, I end. And my humble request to all the faculty members present over here, like it is not like a lecture thing. So you, all of you must be teaching the same thing in your classes, but how practically we are applying in our own institution. So like first thing of the waste management hierarchy is refuse, then reduce. So first we should on our own, we should refuse to use some of the material which is not required. Then reduce our consumption so that the waste generation is less. Then comes the management part. So first, we should be all educated people should educate others to maintain or manage or reduce the waste at the source itself, so that for the management waste going to the management facility is less, so that the burden on the environment is this. I will conclude. Thank you.
Thank you, Professor. I request participant if you have any question, please interact. You can ask.
Good evening, ma'am.
Good evening.
Good evening. Very wonderful lecture. Thank you very much, ma'am. I have one query that is, how can thermal technologies minimize the release of harmful gases like furans and dozens?
Sorry, could you come again? I could not get your question.
Ma'am, my question is, how can these thermal technologies, how they minimize the release of harmful gases like furans?
Harmful gases.
Yes.
Okay. In case of like suppose incineration. So incineration, generally the gases produced are sulfur. If sulfur is present, if nitrogenous compounds are there, it is during combustion they are converted to their oxides. But it should be having the facility should be having gas scrubbing facility. So it scrubs out the sulfur dioxide or NOx from the flue gas before being emitted. So if the gas treatment facility is not there, obviously the incineration will be emitting the harmful gases. And if I go for pyrolysis, it generates syngases. Generally, they are collected and used. They are not emitted as it is. The system is a foolproof system, like where the gas collection system should be there, then it is treated. In case of gasification, it is converted to also CO and H2, then CO is converted to CO2. So CO2 generally it is considered as carbon neutral because that much CO will be again emitted to the atmosphere if it is untreated or if it is dumped in the landfill site. So it is going to be emitted. The CO2 is in case of gasification, and more of the energy is channelized through H2 and other products, and H2 is collected and utilized. Mostly gas collection systems are installed along with the thermal conversion system so that gas can be treated and utilized. It is not emitted.
One more query I have. What financial incentives or policies can encourage investment in this advanced waste to energy technologies?
Yes. In India, as I said, in US, many of the incineration plants are in use. And in India, also 12 to 13 plants are in operation, other 11 to 12 are stopped because of this less efficiency only. So finance thing is like it will be operated in a economical mode. Proper segregation of the waste is done and the design is proper. Like some of the plants are shut because of the inefficient design, like it is designed for a particular capacity and the calorific value of the waste. If our prior calculation is a mistake, then the desired efficiency we cannot get, and the auxiliary fuel which we have to add is much more costlier than the energy we are generating. So incineration plants, they are operational, but with proper design and proper waste characterization, they are running economically with a financial benefit which are operational. But coming to the pyrolysis and gasification, they are till date now not economically viable because whatever slides I have shown, like uh, there are certain operating parameters which govern the waste characteristics and the pyrolysis or gasification output. Suppose the waste is not properly pre-treated, then the pyrolysis, whatever outcome, biochar, bio oil generation will be less. In that case, it is not economical. Therefore, pyrolysis and gasification, they are not a success story in many parts of the world. But if in case of MSW, but gasification or pyrolysis plants are there for a individual waste. Suppose it is rubber, it is only for one agricultural residue, then it is a success story. But in case of an MSW, when mixed waste is there, so
Madam, please unmute yourself.
am I audible?
Yes, please.
Okay. So, in case of pyrolysis and gasification or MSW, in most of the cases it is failure because of the waste characteristics. But for individual waste, pyrolysis and gasification, they are very useful.
Hello, ma'am.
Yes.
Yeah, there are different messages coming from the chat box.
Okay.
Can I share with you, ma'am?
No, no, I can see. I can see. I will
Okay.
see
So
and
based
I
on
will
that, you
answer.
can. Okay. Thank you.
So, what is the Dr. Asmita Das is asking what is the pre-treatment cost for successfully running the incineration plant? Is the energy generated economically viable? Okay. So, pre-treatment cost is, as I said, if it is a mass burning system, pre-treatment is not a major part of the incineration. Only we have to remove some of the non-combustible material, and generally these incineration plants are a part of centralized uh, waste management facility along with landfill. Generally incinerators are used, so it is not a major thing, but energy generated economically viable, yes, if the proper pre-treatment is happening and with a good quality of waste is going to incinerator, then it is economically viable and it is operational now in India. Those which are shut because of this uh, non-viability with the waste quality. I think I answered previously also this question. Uh, Madam, whether we can simulate the first pyrolysis process with the feed of powdered biomass. It is a question of Rakesh. So yes, we can do first pyrolysis with powder, but again, that pre-processing will be a problem because once we increase the surface area of the feedstock, obviously the heat absorbing capacity will be good. But again, drying and making powdered thing is a cumbersome pre-treatment, so it can be avoided. And powdered, for making a powder thing, the waste is to be dried properly. But in some moisture content should be there for better heat release inside the particle. So with some moisture content, it cannot be powdered. So it is not a good idea to make powdered thing, but it can be. Scaling effect of these types. Incinerators are scaled up, but pyrolysis plants, some pyrolysis plants or gasification plants are there in Tamil Nadu, Kerala. So they are operational. But in case of again mixed MSW, depends on the type of the waste. If the good quality of the solid waste with proper pre-treatment is coming, they are scaled up because in many parts of the developed countries, they have scaled up plants. How is poisonous gases like CO removed or scrubbed? Okay. Actually, CO is converted to CO2, are less poisonous. Okay. Carbon monoxide is converted to CO2 in case of gasification. First, producer gas CO is produced, then CO with reaction with water, it is converted to CO2. Is there any possible upgradation techniques available for the bio oil through pyrolysis technique? Yes, of course. Bio oil upgradation are happening so that the non-organic long chain polymers are removed. So there are reactors, but they are actually very costly, and it is in lab scale or research scale thing. Therefore, that is the major demerit of the pyrolysis end product use, like bio oil. Uh, Upgradation, because it cannot be directly blended with diesel or petrol, so it has to be upgraded. Then what measures ensure the economic viability of waste to energy plants in developing nations? Okay. Measures like, one thing is solid waste management hierarchy should be properly planned. The type of waste coming to the thermal conversion unit should be uniform in nature. It is not like today more food waste is coming, next day more dried waste is coming. Some, it is better to feed homogeneous waste. Then measures should be like, government should take a role. Most of the smart cities have already implemented that, like door-to-door collection system in a segregated way. Because in the previous presentation, you must have heard like the Swachha Sathi in material recovery facilities. What they are doing, they are segregating the waste, separating the food waste or kitchen waste, separating the recyclable or combustible fraction. So they are doing it manually. In India, most of the developing nation, if I take Indian context, so most of the sorting, if your collection is in a mixed waste, sorting is a major problem. There are Swachha Sathi who are working 8 hours per day. If you visit any MRF facility, material recovery facility, you can see they're manually just wearing a gloves or mask, and they're doing the sorting. And recently, Odisha government, Bhubaneswar Municipal Corporation, they contacted us like, is there any process how we can automatically do the segregation? Yes, in foreign countries, robots are there for doing the segregation. We are also working on that, like how robots can segregate the solid waste, because manually many people are reluctant now to do the sorting. And also in case of a huge uh, uh, waste generation facility, it will be very difficult to do it manually. So a proper segregation in the household. So mentality change, we should shift to a paradigm like, okay, at home if we segregate it, then there is no other problem with that. If waste, segregated waste goes to the facility, then the process will become economically viable, because segregation and pre-treatment takes a huge time and human involvement as well as cost. So therefore, proper collection is a key to the success of solving this, all these technologies. Uh, is it possible to integrate microbial fuel cell for hydroponic technology in India? Yes, MFC can be incorporated, but MFC is also at its infancy because of the materials used, like the membrane involved or electrodes involved. Again, whether you are asking for the solid waste or the liquid waste, it in MFC solid waste is to be used. First, it should be biodegradable fraction, not inorganic fraction. It should be biodegradable fraction. It has to be liquefied first before feeding into the microbial fuel cell. It has to be digested anaerobically to generate the leachate. Then the leachate should be fed to the microbial fuel cell for the generation of direct electricity. That is the advantage of MFC, where the organic fraction stored in the chemical energy stored in the organic fraction is converted through the microbial catalytic activity directly into electricity without any intermediate combustion process. The energy efficiency is high, but the pretreatment of the solid waste is a challenge, not challenge. You have to effectively generate the leachate out of the solid waste through anaerobic digestion. It becomes a two-step technology. But after that, the generation of electricity efficiency is more because there is no intermediate combustion. Other than combustion application, is any other field of application is available for bio oil from pyrolysis. Pyrolysis oil is generally upgraded to be blended with biodiesel, or it can be used as a crude oil only. Till now, these are the applications. Explain. The syngas is the synthetic gas which is generated out of pyrolysis or gasification. So in pyrolysis, it is mostly methane or H2 or carbon monoxide, carbon dioxide. Okay, I think I have reached the end of the questions. Is it fine?
Thank you, Professor. Thank you. It was a wonderful session. You have highlighted all the technologies in waste management. Thank you. I thank all the participants. Patiently have listened and you have nicely interacted with Professor. If you need any further clarification, you can reach our mail ID is there, manasvi at iitbbs.ac.in.
You will
Or
be
you can
happy to collaborate with the faculty members.
Yes. That's why. If you wish any faculty or research scholar want to interact, please contact Professor. Our complete detail is there. Okay, ma'am. Thank you.
Okay. Thank you, Professor, for making me a part of this LBT. It was a nice interaction with all.
Thank you, ma'am. It's my pleasure, ma'am. Thank you. I thank all the participants and coordinators, supporting staff for organizing this event successfully. Good night, ma'am. Thank you.
Good night. Good night, all.
Good night, sir.
Yeah, tomorrow we will meet at 6:30. Thank you.